look smart today. Hey, it's Arthur coming at you today.
Okay, here we go. 7.4, the second part. We are going to talk about creating inverse functions. Of logarithmic functions and of natural log. Now, when you create inverse functions, what do you normally do to create an inverse?
Flip.
What do you mean by that?
Reciprocal. Flip X and Y.
Switch the x and y, resolve for y, right? Okay, now, think about this. When you have something that's a power, remember our exponential growth equations say y equals b to the x, right? If I switch the x and y, what happens? I get x equals b to the y power, right?
Yeah.
How do you get something out of the power spot? You have to use what?
No.
No.
You have to multiply. No.
No, not a radical, because we don't have a number here. Okay? Okay, if I have natural log, I'm going to use e. If I'm using the base log of 10, I'm going to use some ln. No, ln goes with natural log. Common log is base 10. So what happens is I have to say something like this. X equals, okay, and you have to say something like log base b to the b of y, something like that, so that it cancels to give you y equals x, okay? So we're going to work on canceling things out by solving that way. It's a pattern, so it's going to be easy once you figure out the pattern, because it's going to be the same thing every time, okay? When I plug in, if I have g of x equals log base b of x, the inverse of that is f of x equals b to the x, okay? Because it's my base to my number that I get to my answer, okay? The base to the power gives me my answer, okay? So g of f of x means that I'm plugging the function of f into the spot of x on the function of g, right? When I do inverse. When you do inverse functions, what should you always get out? What should always be your answer?
No.
What should my answer always be when I plug a function into a function? Not 0.
A whole the same.
It should be the.
You should always get x out.
Well, yeah.
Okay, on your test from chapter 6, some of you didn't do that right. It was the first problem, I believe, on that second page. Okay, so when I plug this in, what happens is this. Watch, I'm going to get x out. Because log base b of b to the x cancels. The log base b and the b cancel, giving you x. Over here, when you do b raised to the log base b of x, these cancel, giving you, that's how you know it's an inverse.
Oh my god.
Okay? We're going to look at graphing inverse functions today too, but first we're going to talk about simplifying this. Now, don't make this harder than it is. Okay? You're not using your calculator, you're using common sense. If I have 10 to the log of 4, what base is with that log right now? No? 10, because if there's nothing there, it's a 10. So I have this technically, it's written this way, right? Log base 10 of 4 like that. Okay, so if I want to simplify it, what is 10 to the log 10? What happens with that?
Crosses
It
out.
crosses out, so what is your answer?
4.
Boom. My answer is 4.
That's.
Now, look over here. Your base is 5. Is this a base of 5? Or is this number in 5s?
No.
No, it's at 25 right now. Can I get it to something with a base of 5? Yes. How does 25 relate to 5? What is it?
5. This is
5 squared.
Yeah.
So we're going to change it so that it says log base 5 of 5 squared to the x. What do you think is going to happen?
Take out the 5.
These are going to cancel, leaving you with 2 times x, which is, and that's your simplified answer. So on all of these that you do tonight for homework, you want it to match whatever your base is. So if my base is 3 and my number is 27, I got to say 3 cubed is 27, right? Okay? So that the log base 3 and the 3 can cancel out. Does that make sense? So you have to be good with arithmetic. Multiplication facts. Okay? So if I have something let me think here. If I have one that says log base 7, okay, let's say it says log base 7 of 7 to the negative 1. Okay? What ends up happening? What's my solution?
-1.
Negative 1. These cancel, I get negative 1. Okay? What happens if I say something like, e to the ln of 20?
20.
20, why?
The E and L.
The e and ln are the same thing.
Yeah.
Okay? So when you see e and ln, they automatically cancel each other out. Okay? So that's the first step of what you're doing on your homework tonight. Simplifying expressions in that function. The next is you're going to find the inverse. How did you tell me we find inverse? You do what?
X and Y.
Change x and y, resolve for
Y.
y. So over here I'm going to change x and y, right? So I'm going to get x equals 6 to the y. Okay. If y is in a power spot, okay, if y is in the power spot, how do you get to set it equal to y now? If y is in the power spot, how can I get it to say y equals now?
You have to divide by Y.
You can't divide by y.
You.
Okay, think about this for me. If you have something that says log base 2 of x equals 6, how would you rewrite that?
6
squared.
2 to the
6
equals x. How can I rewrite that into that form?
So
6 to the Y.
Bless
Y
you.
to the 6.
no,
So
6 to the Y. Log
Yes,
6
log 6.
Y equal.
No,
No.
Log 6x.
yes,
X. That's
Equals
yeah.
Y.
equals y.
There you
Here is my inverse function. Okay? So your inverse function, if it is an exponential form to start with, your inverse is going to be in logarithmic form. If it's in logarithmic form, your inverse is going to be in exponential. Okay? If it's in e, my inverse is going to be in natural log. If it's in natural log, my inverse is in e to a power. Okay? So these right here are inverses of each other. And here's why. If I plug this equation in to the x of that equation, right? Log base 6 of 6 to the x equals y, what happens? Cancel and you get,
X equals Y.
right, so it's the inverse. Yes, what's your question? You always flip if there's negative exponents. Okay, so when you are doing inverse functions, you have to remember that. You're going to get in these answers logarithmic functions, okay? Just rearrange it. It's not as hard as you think. I literally rearrange this. Because I have it this way, I say log base 6. Remember, this is always my base. It's always about base. Okay, log base 6 of x equals y. Okay, over here, how would I change this one?
You have to distribute.
What do I have to do first?
Oh, change it.
Flip the X and Y.
X equals the natural log of y plus 3. Okay. How do you get rid of natural log? E, right?
Yes.
E. So I should have e to the x equals e to the natural log of y plus 3. What happens here?
The E and the L cancel.
Yes, the e and the ln cancel. E to the x equals y plus 3. What do you do now?
Subtract 3.
Subtract 3. And e to the x minus 3 equals y. There's your inverse function. So because this was in natural log form already, I have an e to end with. A power. E to a power. Okay? So if it's in natural log or if it's in logarithmic, I'm going to something with a power or an e with the power. If it's in a power form, I'm going to logarithmic or I'm going to natural log.
How do you know if it's natural?
Because it's natural log if there's an e.
But you,
And it's e to a power if there's natural log, period. Those are the two that go together. Otherwise, it's logarithmic. Anything else is logarithmic function. Okay? The only time I'm going to throw e in there is if there was an ln in the original, and the only time I'm throwing ln in there is if there was an e in the original. Otherwise, logarithmic function always. Now, we have to talk about graphing these. Okay, so graphing logarithmic functions. So you can use inverse relationships between exponential and logarithmic functions to graph logarithmic functions, okay? Because something is the inverse, it means that it is the mirror image of it, right? It's the opposite, basically. So if I have a function like log base b of x, the inverse, okay? That would be the inverse of y equals b to the x power, correct? Okay? When b to the x power, when b is greater than 1, I have what type of function? What type of graph am I creating when b is greater than 1?
exponential growth.
Growth. I'm talking about growth, okay? So when b is greater than 1, I have this growth happening, yes? Okay. My inverse function reflects over the line y equals x, which creates this dashed mirror image right here, okay? So what's happening is this point 0, 1 is reflecting over here to 1, 0, and vice versa. All these points are reflecting over, so it's going to mirror what my growth would look like. Does that make sense? Okay. When you come over to something where b is less than 1, but it's greater than 0, what type of function do I have going on? Decay. Good, yes, decay. So here's my exponential decay function right here. See that? Boom. Now watch this. This is still my axes. The x equals 1 is still my reflection. You see how it cuts through that graph? Okay. So that's what makes this graph look a little different. This point 0, 1 still reflects down here at 1, 0. So all these points above this dash line are reflecting down. All the points down here below the dash line are reflecting up to this part right here. Okay? So my graphs look a little different. Now, let me talk to you about this. When we do our normal exponential functions, what's always my domain? No. All real numbers. And then my range, I determine by my y what's shifting or what's going on, correct? Okay, when you are dealing with inverse functions, and we'll take a look at why this happens. When you are dealing with inverse functions, your domain depends on what's attached to your x. Your range is always all real numbers. I'm going to show you why. It makes more sense when I show you why. Let's graph some, and you're going to be able to tell why that works, okay? Now, when I go to graph, can I graph y equals log 3 of x? No, because I don't have a button in my calculator that has a base of 3, okay? But what I can do is I can create this into exponential form, okay? I can create it by doing what? How would I rewrite this in exponential form? Yeah, x equals what? X equals what?
Would it be 3?
Uh-huh. And then you need a power in there, so what is it too?
The x?
No, you have x equals. Okay, so I have x equals 3 to the y. Okay, if I rewrite this, it's going to say x equals 3 to the y. Okay? That means what am I plugging in for? I'm plugging in for y, and I'm getting x outputs.
Oh.
That's why my domain is not all real numbers anymore. That's why my range is all real numbers, because I'm plugging in for the y. So when you go to graph any of these functions, you have to change them back into exponential functions first. So if it's an inverse function, your exponential function should have y in the exponent spot. Okay? Meaning I'm going to plug in -1. I'm going to plug in -1, 0, 1, and 2, okay, like I did before. But this time I'm plugging into the y, not the x. When I plug -1 in, what do you get out? 1/3. When I plug 0 in, what do I always get out? 1. When I plug 1 in, what do I get out? And when I square it, what do I get out? Now, when I graph this, I'm graphing 1/3 -1. 1/3 -1. I'm graphing 1, 0. I'm graphing 3, 1. And I'm graphing, oh, I lied. No, okay.
Yeah, you're
And I'm graphing 9, 2. It's way over there. Okay, so this is what my graph is looking like. My domain, in this case, is what? 1.
Greater.
X is greater than what?
0.
0, because it's not crossing this y-axis into the negative, right? X is greater than 0. What's my range? All real numbers. So when you're graphing exponential growth and decay, you have the opposite for domain and range. You have to determine your range. Your domain is always all real numbers. When you're graphing the inverse function of it, the domain and range change. The range is always all real numbers. The domain you have to decide. Now, how would I rewrite this to graph this one? X equals 1/2 to the y. Good. So then I'm going to plug in -1, 0, 1, and 2 again. Like I said, just stick with easy, simple numbers, okay? This is my y, this is my x. If I plug -1 in, what do you get out? 2. If you plug 0 in, you get, when you plug 1 in, you get,
1/2.
and when you plug 2 in, you get
1/4.
1/4. So I'm going to graph 2, -1. I'm going to graph 1, 0. I'm going to graph a half 1. I'm going to graph a fourth 2. What's your domain? X
Less
is
than
not less than 0,
0. Greater than.
greater than 0.
Oh, okay.
And what's your range?
All over the place.
Beautiful. We're going to do one more, I think. Yes, okay. So here it wants us to graph this function, okay? We're going to graph this like we did other translated ones. Remember how last week I said, let's just graph the function and then we'll translate it? We're going to do the same thing. So let's change this. How do you change log to x? How do I change that? What do I need to do?
X equals 2 to the y.
Okay, x equals 2 to the y. We're going to graph that, then we're going to come back and shift these. Does that make sense? Okay, we're going to make it simple that way so that we can solve some stuff. Or so that things are a little bit easier for us. So, let's do this. Okay, so let's graph x equals 2 to the y, which means I'm plugging numbers again in for y, right? Y, x, let's plug in -1, let's plug in 0, let's plug in 1, and let's plug in 2. If I plug in a -1, what do you get? 1/2. If you plug in a 0, you get
1.
If I plug in 1, I get
2.
and if I plug in 2, I get
4.
good. So we graph these first. We graph 1/2 -1. We graph 1, 0. We graph 2, 1. We graph 4, 2. Now, with those points, I got to come back up and shift. So look right here. Okay, what am I shifting?
-3, 1.
Okay, I'm going left 3, up 1 on all these. Okay, so left 3, let's see here. 1, 2, 3, up 1, right? I lied, 1 should be there. Over 3, 1, 2, 3, up 1. 1, 2, 3, up 1. 1, 2, 3, up 1. Boom. Okay, so my growth, or my function, my graph, if I could speak correctly, that'd be good, is going to go like this. Now, we gotta talk domain and range. Okay, domain. If usually I look at this for the range, where do you think I'm looking for the domain? So what is domain in this case? Domain is what? X is greater than, not 3, negative 3. It's always opposite. X is greater than negative 3. So that means technically down here, or over here I should say, there's like this line here, right? Oh, shoot. I don't know how I do that.
Hello? Hello?
Okay, so there's technically, okay, so there's technically this, okay, well, there's technically a line here, right, that it can't cross. So it's gonna hit here and it's gonna curve down like that, yeah? Okay, what's my range? All real numbers. Okay, so that is the only thing you have to remember. What you need to ask yourself is this: is my X in the power spot or is my Y? That will determine which one is all real numbers. And then from there you can decide what your domain or your range is left. Okay? Otherwise you're graphing it literally the same way we did them before. Plug in numbers, make them easy, -1, 0, 1, 2, get stuff out. Okay? Rules of exponents still apply. Get busy on your homework.